Going to be explaining is binary ionic compounds type 1. So for this type, I'm going to be explaining the formulas first, and then afterwards I'll also explain the nomenclature, which nomenclature is how they're written out in word form, basically. Basically like their name. So for the formulas, you're gonna get an element compound, like for example magnesium oxide. So what I like to do for this type is drawing out their Lewis dot diagrams. A Lewis dot diagram is writing out the symbols as so, and around them you draw out how many valence electrons they have. So if you look at your periodic table, magnesium has 2 valence electrons, and oxygen has 6 valence electrons. So you're going to draw those out, 1, 2, 3, 4, 5, 6. And your goal in this is to stabilize both elements. To stabilize both elements, you're going to have to fill up their shells, which means to a, just like how we've learned in class. So in this case, in order to stabilize oxygen, it would need 2 more to add up to 8. And magnesium has those 2 electrons. So what you're going to do is you're going to transfer both of those. So you're going to do 1, 2, and you're going to take those away. And once you've taken those away, you can finally consider the element stabilized, which means that you've given away all of its electrons, which gives the idea that we're trying to achieve. So you're just going to cancel those out, and your formula for this would just simply be MgO, magnesium oxide. Now, another example that you could do for this, let me just erase this real quick. Another example that you could do is strontium fluoride. And again, what you can do with this is the Lewis dot diagrams, which would be Sr, F, and strontium has 2, and fluoride has 7, which you would just draw that out. 1, 2, 3, 4, 5, 6, 7. Now in this case, fluorine would only need 1 valence electron in order to be stable, so you're just going to add that and take 1 away. But if you notice, you'll see that strontium still has 1 valence electron that it needs to give away in order to be stable. So what you're going to do for this is you're going to add another fluorine, and you're going to draw out the electrons again. And you can give away the last electron from strontium and add it to fluorine, which would then make your formula Sr for strontium, and then fluorine. And since you have 2 atoms that you wrote out for fluorine, you're just going to write a subscript of 2. Now for the nomenclature, it's pretty easy for this type. So what you're going to do is take any formula that's given to you. So for example, CaO. So for this, you're going to always write out the first element as it is. So that's just going to be calcium. And for the second element, you're going to write it as it is, but you're going to change its ending to ide, IDE. So in this case, it would be calcium oxide. And to give another example, you could do aluminum and phosphorus. And again, to write this out, you just write out aluminum as it is, and then phosphorus, it's a little bit different, but you would just write out it with the same ending, and that would turn it into phosphide. And that's basically what the type 1 is. So it's just, for the nomenclature, just adding "ide" to the end of it, and For the formulas, it's just writing out the Lewis dot diagrams, the valence electrons, and then adding how many ever atoms you need of each element in order to stabilize them, and that's pretty much it.